Hi, everybody. Today we will look at the exercises, the hands-on exercise on MySQL. Um, well, actually, data manipulation language, so-called SQL statements, will be discussed. Our hands-on is particularly on MySQL database. I wanted to recall that you already created the database in the last session and also populate the data. So we are going to go back to that database and practice how we can retrieve data from there. Okay. Um, so in the first phase, we're going to write SQL the expression directly. Okay, and we can execute it. In the later part of this class, we're going to include the SQL on the host language. The language that we choose is Python. So SQL embedded Python code can be executed. So inside of the code, uh, what it does is to access a database, open the database, and whatever the expression requested from this Python code uh, to be executed within MySQL. Then MySQL return the result. That result can be further displayed according to the Python code that you design. Okay. So theory of SQL. SQL is you can think of SQL language is a set-based language. Of course, this is a simply declarative language. SQL language does not describe how to get the data, but SQL language describes only what we want from my database. So how to do will be done by database management systems. So what to do is on us. So we have to write SQL statements and post that SQL statements to DBMS, in our case MySQL. Then MySQL has the software packages in it to optimize given SQL expression. So basic idea there is given SQL statements that optimize or convert declarative language. Declarative language is like select from where clause. That declarative language to real code programs that we do. If MySQL is implemented in C, then the language that optimizer to convert to is a C code. And then that C code is executed within MySQL. Okay, so basically SQL is declarative. It is not procedural language. In other words, that is non-procedural language. Non-procedural language. Okay. Set-based language means SQL language is looking at the data in columns and rows. Okay, so data is a set of columns, or data can be viewed as a set of records. Okay, anyway, it is a set. So set-based language. So set of columns or set of the records. So SQL statements enables set operations. So we can do union or you can do minus. Union is okay in MySQL, but minus, this language is not available by MySQL. So yeah, so it depends on the products that you use in real hands-on labs. And also because it is a set, we can think of within set, you can consider an element. So set element operation is also possible. Existence is also possible if something existed in these records. Exist in a record. SFW, you can see that is a set because the select from where clause returns us a table. So table is nothing but a set. So whether any element exists in that given set, that operation is possible. And also set membership. If we have an element, we can check that element is in the given set. So all of this, in theory, is a set-based operations. So knowing that, remember that we created the database in the last week. So we'll start some of those today. So I am going to squeeze a little bit of those and push that aside. Bring terminal, and for Mac users, you need to first change it to USL local, and then change another directory, MySQL -9, and then go to binary directory. Here I can call MySQL, and username is Jayun525. Remember that we created the user within MySQL in the last session. If you forget, then you can redo it from going back to the recording that currently posted. So that recording helps you. So first we need to see databases. Then we can remember this is the database that we looked at, right? So we're going to use Sci525 and show tables. We created a class, department, enroll, and student tables. So let's look at, and also we populated that, right? So I want to see each of those classes. So select a star from class, then I can see all the data that we populated the last sessions. And then select star from the department. We have computer science department and cyber security department. TID is CS or cyber. What other? We have enroll and students. So select from student. We have that many students. Bob, same name, but different CWID. 2 Bobs, one in cyber, one in CS. And then finally, star from enroll. So we know CWID 1111, register CID 500. Who's this 1111? Bob, right? So Bob registered CID 500. What course is it? So if you go to class, then 500 is Intro to Cyber Security. So Bob takes Intro to Cyber Security. Then we can also see who's teaching that course, right? That type of things is if you see here, we have 4 tables. Those 4 tables are like each of those is nothing but a spreadsheet. It has columns and rows. Among those tables, are there some relationships? If we look the table, columns and rows, not necessarily until we specify it. For example, CRN here, class CRN is the same as the enrollment CID. Okay, and then enrollment CWID is nothing but the student CWID, and student major is nothing but the department DID. So what department the Bob 1111 is enrolled in? Give me the title, give me the name of the department. Then it should go cyber and then DID here because DID should be the same as the major here. So come back here, then the name of the department is cybersecurity. What about the Bob in 1112? What is the name of the department? Then the code, major code is CS. Come back here, CS is nothing but computer science, right? That is somehow the logics that we traverse from one table to another table. When we traverse from one table to another table, then we traverse based upon the common data. Major here in the students is nothing but department ID in the department table. So we need to match the values. Here is we see cyber, then match with that. Here's we have CS, then match with that. Okay. We can do, for example, insert into department values and then math department, and then department ID is, let's say, empty. Let's say mathematics, and department ID is a math, and the department chair, let's say, logic. Okay. Select, start from department. Then we have 3 departments, all right? Mathematics, cybersecurity, computer science. We have different department IDs and different chairperson. And select, start from student. Then we have 5 students. So with this example of the database, we can say here, list the course taught by John. Is the name John, or yeah, we have John. And then class, do we have a class? Where is the class? There's the instructor, and then, oh yeah, there's the instructor. Therefore we can, yeah, simply this one, list courses taught by John. So there's the instructor once, list of a course title is here. So we simply get the information from the one table, right? So we can do select course title from class where the instructor is John, and hit return. Then we can see 3 courses taught by John. If you go back here, the classes, then John takes 3 courses, right? That's what it is here. List the students who study cyber major. That's simply that we can see here in the student table. So select student. So we can say we list the name from student where the major is cyber. So Bob, Adam, Peter, those are 3 students studied cyber. And now we want to join. This is a little bit of, this requires 3 tables. So let's make it simple. We have select star from student, 5 students. We have select star from department. We have 3 departments, okay? Right now, if you see here, the scenario here is that the Department of Mathematics, there is no students enrolled. Potential reason is that that department is newly established, so no one enrolled there. But we have students in computer science and students in cybersecurity. That's what happens here, right? So now we want to join. Who is in what department? Let's say, for example, what is the department name? I want to do, we have here, this is the name in the department. This is another name in the students. So instead of, say name here, name and name, first name is student name, second name is department name, then this guy may be confused. You cannot get anything, right? Student, and I want to get student and department from there. Then you may say here, the first one is the name in the department. Then you need to say table name dot attributes. So student dot name, and the other one could be department dot name. So we need to specify clearly, explicitly, which name is from where, unless otherwise it gives you an error, right? So every time that you specify here students and department, then you need to say student and the table name here, right? Let's say I want to join these 2 tables, this table and that table, so that I want to see who is in what department. I want to see only 2 columns, student name column and department name columns. I want to a short list of those from this. Let's assume this is an SQL statements. So hit enter. Then what happens? The outcome here is that Bob is in mathematics department, Bob is in cybersecurity, Bob is in computer science. I think the first Bob is the ID 1111. Second Bob is 1112. Bob is also mathematics, cybersecurity, computer science. Chris, mathematics, computer science, and computer science. Adam, all of those 3. Peter, all of those 3. So what happens? Our join operation is to list table names, 2 or more table names. Then these 2 tables can be joined. So that I want to list student name and department name. But apparently, the outcome gives us the list of those. Many of the records here do not make sense. Some make sense. Okay? So if you do this, only select and from close for join operation for these two tables, then what it returns to you is to match all possible combinations. Match all possible combinations. So it doesn't reflect the real world. What reflects to the real world is, here in this case, we need to say major in student needs to be the same as DID in the department. So this guy, major here and DID here, if we only this guy, if they are the same value, then that's the real, that is the reality, right? That is what we want. So what should we do in this join operation? Then given this, we have to do one more thing here. In the where clause, then we have to do, for example, student major should be the same as department dot D underscore ID. So D underscore ID. In this case, it shows to me that Bob is in cybersecurity, the other Bob is in computer science, Chris is computer science, Adam is in cybersecurity, Peter is in cybersecurity. Remember that in the mathematics, as I said, so it's a newly established department. So no one's enrolled. If we do not have this where clause, if we do only this, select and from close for join operation, then it gives us all possible combinations as we looked at it here. Therefore, we need to put the where clause. In the where clause, we need to match which attribute in one table should be the same as which attribute in another table. In other words, when we design, the ID is a primary key in the department, and major is a foreign key in the student table. So this foreign key should be the same as the primary key in another department. So we need to say that, right? That is this where clause. All right? That's what why the join conditions we need to put here more. Otherwise, long list. So join table should be here. We need to have join conditions. In this case, there are three tables joined: student, enroll, and course. So one condition match the two tables, and the other condition match the third table with one of those two tables. So whole three tables needs to be matched. Then we need to have two conditions, right? Okay. As we looked at here, rather than we spell out the table name here, if we want to do little simple way using the alias, then we can simply say here student followed by another symbol, we say S. Department followed by D, that is alias. If we say that, then we can simply, we don't need to spell out all the table names here, but acronyms, alias only. This will be much simpler, right? We simply say like this. And also department. Then we have that, right? The other one is we have a name, one column, first column is name, the other column is also name. If you want to make it new name, then we can say s.name as student, and then d.name is department. Then it can give us more sense, right? This student is in that department, and so on and so forth. So we can rename this. If we want to rename it, then we need to say as followed by new name. This new name is only effective one time for the display, only for the purpose of display. Okay. List who takes what course. This is, I think we did similar things, is who is in what department, what majors. List who teaches what students. Okay. Let's go back to, so who teaches, so teacher's name, who teaches. Let's look at select star from class. So class has who teaches. This table does not have a student name, right? So we need to see which table is needed. So in order to get to student name, then we need to do select star from enroll. Then here, let's say Chen teaches cyber, intro to cyber, CRN is 500. With this 500 value, come back here, then 500 value is enrolled by CWID 1111. Still, we do not know who is CWID 1111. That's available in student table. So when we come here, then we know that is Bob, right? So those three tables needed: class, enroll, and students. Those three needs to be joined. If we join the tables, then we need to specify the join condition. When you make it join, then based on what condition are you going to join them? Here, class and enroll needs to be joined based upon CRN and CID. And enroll and students, two tables are joined based upon CWID here and CWID over here, right? So clearly from class matched with joined with enroll based upon CRN and CID, and further we join with the students based upon CWID here and there. Okay, so that is the scenario. So we need to write that down here. So select. So we have a student name, right? So let's say s.name. We need to put instructor first. So class as instructor. So c.instructor, comma s.name. Okay. And then from class, alias c, enroll, alias e, student, alias s, and then we need to take care of the where clause. In the where clause, class has CRN and enroll has CID. So c.crn should be the same as e.cid. Here, enroll has CID and class has CRN, right? And then we can have one more. We connect class and enroll based upon this, but yet this doesn't connect to the student, right? So we need to find out common attribute with the students. So in order to connect with the students, then we can connect from class to students, or we can connect from enroll to students. But there is no direct connection from class, so we need to connect from enroll. So in the enroll table, we have CWID. In the student table, we have CWID. Those two values need to be the same. So enroll CWID should be the same as student.CWID. Okay. And then semicolon, hit enter. Then John teaches Bob, Chen teaches Bob, John teaches Bob, Usman teaches Peter, John teaches Bob. Okay. Okay. And then next one is aggregation. What is aggregation? Aggregation, if we say aggregation is like a collection, right? And then there is an aggregation function. Aggregation function is nothing but the function that can take multiple input and returns one output from multiple input data to produce one output. There are so many such functions available, and those functions are called aggregate functions. For example, here, count. Let's say we have a group of students. If we say count, then the input is those all the students. Output is only one number, right? Are there 10 students or 100 students? Count returns only one number. Input, whatever the given data sets. For example, if we say average, then input multiple data. Average is one number only, right? What is the average income of the city? Then only one number. Maximum, there is only one number also. Minimum, only one number. So those functions are called aggregate function. That type of things can be done in our MySQL as well. Okay. So here, if we say that is something that we need to do, group by. I want to group by instructor. I want to group by instructor. Then Chen, whatever the Chen teaches, I want to group. Whatever the John teaches, I want to group them. Whatever the Usman teaches, I want to group them. If I group them, I cannot specify each individual student name, of course, right? So this is not possible. This is not possible. So instead, if we say count, count is possible, right? Rather than spell out the student's name, we can say how many names, or how many CWID, whatever, right? That is possible. So hit enter, then we can see Chen teaches one student, John teaches two students, and Usman teaches one student, right? That is possible. Again, here, if you do not want to show count open parenthesis s.cwid, you want to rename it, then you can say number of students. Hit enter. I think that the pound sign is not taken, that symbol. So the other one that you need to do is simply number of students. Then it returns. Okay, rather than this, you can say NO underscore students. Then clearly this explains. Another thing that I want to show, who is what department, right? Here, right here, I want to copy and paste this. Student name, in order to clear that, I want to see here student CWID. Hit enter. Then Bob 1111 in security, Bob 1112 is computer science, and so on and so forth, right? And then if I want to do a little bit in different ways, let's say department first, and I want to put department name first here. Same result, but I want to swap the columns in order to show something else. So cybersecurity, we have students 1111. Computer science, we have that students, and computer science, cybersecurity, and cybersecurity. Again, you can do so which department is how many students. Then you need to do here group by department name, and then how many students. So here in this case, count. Hit enter. Then cybersecurity 2 students, computer science, cybersecurity 3 students, computer science 2 students. How many departments we have? We have one more department. Is there anything that I can bring here, mathematics, and then 0 here, or none, null? Therefore, we may be able to see whole picture of the major in our university. So cybersecurity, computer science, and mathematics, but students are there. And then even if there is no enrollment, I want to see what department that is, right? I want to see that. In order to include that, then you need to do left to join here, left to join. So what you need to do is here, left to join, department D, left to join, student S, and then you need to say that left to join should be based upon that conditions. I'm not sure if we can make it no. I want to make it 3 lines, but if I hit enter, then it executes. But anyway, I want to see here, select. So we have a list of departments and the number of students, but I want to include not only something actually matched with the students, but even if it is not matched, I want to list those unmatched elements should be displayed here on the left side. That is for left join. So I have here a department that is on left. In this left join, I want to include all the data, all the records in the department should appear here. And then students. But this department and student needs to be joined based upon not just a simple join, but left join based upon student major equals department DID. But when I do this, I want to do, let's try to do without group by, okay? I want to do this, but without group by. If we don't do group by, then we need to say not the aggregate functions to be here. If we use aggregate function, then we need to use a group by. What is the aggregate? So multiple inputs, single output function. That is aggregate function. In order to have a multiple function or multiple data, then we need to group the data based upon what, right? So group by is needed. So it is not the case, then we simply CWID. Then it gives what? Computer science Chris, computer science Bob, cybersecurity Peter, cybersecurity Adam, cybersecurity Bob, mathematics null. So we know here this guy is not matched between the department and students. Still, we want to include this if we want to do left join here. We need to do a little further with the aggregate function. So I want to do group by department name. Because I do here group by, then my select attribute needs to be the aggregate functions. So I need to do count aggregate functions. So hit enter. Then I clearly see computer science, we have 2 students, cybersecurity, 3 students, mathematics, 0 students, right? Okay. That's the same as that, and then how to make a database efficiency. Okay. What is the purpose of a database? A database is not only to store data, but also we need to retrieve the data efficiently. In order to retrieve the data efficiently, then first thing that we need to create. Then we need to do index creations. So we need to restructure the data. Therefore, data can be retrieved fast. In other words, in this case, create index, we want to based upon employee ID, employee code. Then we can, let's assume that employee table is more frequently accessed by employee code. Then we need to get our table ready to serve that kind of query, right? Because we have so often, so frequently the same query requested to find the employees based upon the employee code, E-code. Then we need to reshuffle our tables so our table can be well structured based upon E-code. In that case, we need to do index creation. Before we do that, view creations, we can still create a view. Let's say we can select student from, if GPA is 3.75, then we can, this is SQL statements, right? These SQL statements may be able to be used so often and also useful for the dean. Therefore, we can construct a dean's list, okay? Honor rolls. So rather than execute this, is there any way that we can create temporary tables? So without execution, can I simply read the tables? Yes, you can. Then you need to do create view and then view name as and given SQL statements, then this having this, you don't need to do uh, execution with the where clause. Uh, this where clause is nothing but the conditional statements. So a lot of the computational power needed. But if we have materialized the table, then we simply use it, right? So how can we materialize the data from this expression? Then we can use the view creations. So we can have views, we may have index, right? Then how can we use it? So view can be created in this way. So we can do, so course taught by John. Then this is SQL statements, right? We looked at this. And then we simply make it, let's make it here, create view courses taught by John as, and then we can do select star from class where instructor equals, then there is created. So from this, we simply select star from courses taught by John. We don't do any the where clause, anything, because this is already materialized. So we simply, this is created, we simply use it, right? That is the view. So view is a really good concept that we can make table ready to serve if the table is frequently required by user. Then we can make this table one time and this table is ready. Then we don't need to execute this every time. We simply show it. Alter is also possible. If you want to change select star from class. Then we have a CRN number, title, and instructor. But we do not have what the department offers that course. We want to create it. We already created the table. So rather than drop that table and recreate and repopulate the data, we still keep the current data, but from this time, we want to show something, okay? In that case, we need to use alter. Alter, table, class, and we want to add offered. What's the type of that offered? Offered is by the department, right? So we can do varchar. And go back to that class that we have here offered. Currently, all is null, right? Of course. Then we can do something else. Manually, we can add some values. Let's say insert into class values I'm not sure for that. You can do update class set offered to cyber where um, CRN is less than 540. Okay, then everything is a cyber here, right? We can do update the class, and we need to set and attributes equals, this is the value. You don't want to set all the cyber, only CRN is less than 540, then they are cyber. And 545, so equal to 545, then yes, then also you can make here. So 545 distributed software developments, then that is offered by the CS. I think all others are offered by the cyber department, right? So we do alter the table structure so that we add one more, and we can add the data there after that. So after we alter, if we want to add the data that's specific, the attributes, you need to use update rather than insert. Modify attribute is also possible. If you do, for example, alter table, let's see another table. Class student, let's say department. Let's see the structure, DSC department, then 3 attributes, name, DID, and chair. So if you want to alter table department, modify column chair, the type is, rather than text, we want to change it to varchar and 15. Then it can be changed. So previously we have a name text and varchar 10 and text, but now we have a text, varchar 10 and varchar 15. It can be changed like this. Okay, I think that's it. All right, so in this way, now we complete SQL statements that we do it on command line, right? From next week, what we will do is we're going to include the SQL statements in Python code. So rather than come back here and do SQL expression on this prompt, MySQL prompt. So without having this MySQL prompt, without accessing the database, we can simply execute Python code. Then Python, on behalf of us, Python code can access MySQL and execute SQL statements and take the output from that SQL statements. Okay, so a lot more handy and powerful. That is the way that you can say to the job market, do you know database? Then you can say, yeah, I know the SQL statements. I know SQL embedded Python code. So I can code my Python to access database. Okay, a lot more powerful. So that'll come next. Okay, thanks so much. See you later.